A popular type of window is the Norman window, which has a semicircle on top of a rectangle as shown to the right. The total perimeter for this window is 8 metres. In part A, we want to find an expression for h in terms of r. To do this, we'll use a perimeter equation. So we know that our perimeter is equal to 2h, which takes into account this side length and this side length, plus 2r, which is the bottom length, and then we need to add on to that the curve at the top, which is half the circumference of a circle, which is just pi r. And all up, that's got to equal 8 metres. Therefore, we can get h by itself, so we can go h is equal to, and we've got 8, and we're going to subtract 2r, subtract pi r, and then divide by 2, and that gets h by itself. And if we just simplify that slightly, we get h is equal to 4 minus r minus pi r on 2. So that's an expression for h in terms of r. For part B, we want to find an expression for the area of the window A in terms of r. So our area is going to be equal to the area of the rectangle, which is 2r multiplied by h, and then we want to add on pi r squared, which is the area of a circle, and we divide that by 2 to get the area of the semicircle. Then we replace the h with the expression we found in part A, so we get 2r, and then we multiply that by 4 minus r minus pi r on 2, and then we've still got added on pi r squared on 2. And now if we simplify that, we get our area in terms of the radius is equal to 8r subtract 2r squared minus pi r squared on 2. So that's a of r, which is the function of the area of our window. In part C, we want to find the maximum possible area that the window can have, and we want to state this answer correct to 2 decimal places. So we know to find the maximum we can use calculus, which means that we're going to take the derivative a dashed of r and set it equal to 0 to find any stationary points on our curve. If we do this, we get 8 minus 4r minus pi r. That's the derivative of a, and we set that equal to 0, and solving gives r is equal to 8 divided by 4 plus pi. So to find the area of our maximum window, we simply substitute that value of r into our area formula. So we're going to substitute 8 divided by 4 plus pi into our area function, which we found in part B. And if we do that on our calculators, we get that that is equal to 4.48 meters squared, and that answer is correct to 2 decimal places. So that's the maximum area that this window can have.